My name is Mike Sorrentino, and today we're going to talk about finding set and drift. Now, what exactly is set and drift? Set and drift is the true course of the water and the speed of the water against the hull of the boat. And to do that, we'll be using questions that will give us our starting time, our departure time, our arrival time, our true course or our magnetic course to steer, which we'll find out then our true course, and our starting point and a dead reckoning point. Before we do anything, the first thing that needs to be done is we need to find out what our true course is and what our distance is. Now these will utilize all the things that we've learned so far in the course, okay, including how to chart points, how to go from true to magnetic compass or from compass to magnetic true, and also how to find your distance using the D Street formulas. So let's get started. The first thing is we're going to take a course, and we'll use this question here. Your position is at 1516. Your position is latitude 11.3 degrees north and longitude 48.6 degrees west. We're going to go on a course of extending magnetic compass to 300 degrees, and we're going to be moving at 9.4 knots. At 1600, our position will be a latitude of 41 degrees 14.0 nautical north and a longitude of 7158.1. So the first thing that we're going to do is we want to find our true. To find the true, okay, we're going to use our formulation for what we call the TVMDC. Now in this case, we're going to be working from our compass magnetic heading to finding out our true. So normally you would put down TVMDC, true, variance, magnetic, deviation, compass heading. Since we're going from compass to true, we're not going to need this part of our equation. The question stated that we are starting at we were heading at a compass, a magnetic compass heading of 300 degrees. So we will start at 300 degrees. Our deviation on our vessel, okay, that we have from our chart, we know that the deviation, if we look it up, is 0 degrees, making it simple, and that our magnetic is 300 degrees. Now, when working in Block Island Sound, the variation is 15 degrees west. So our variation becomes 15 degrees west. And since we're going from compass, standard magnetic compass, to true, we subtract our west. So when we subtract that, 285 degrees becomes our true heading. Okay? The next thing that we need to find out is our distance. Well, we were given a couple of pieces of information. First piece of information that we were given, okay, when we need to find either distance, time, or speed, we need to have the other two. And here's the formula that we've used before, which is D Street distance times 60, our speed, and our time. So what was given to us? We know that our speed, we said we were traveling at 9.4 knots. So we can put 9.4 knots into our equation. Now it says time. Well, it gave us a departure and it gave us an arrival. It said we left at 15:16 and we arrived at 1600. Now there's several different ways to do this, okay? But in this particular equation, okay, you can see that it's less than an hour. So if we reduce the hour here and change this to 60 minutes, and we subtract 16 from 60, we come up with 44 minutes. So now we have our time. And if we take 9.4, and you times it by 44 minutes, and then you would divide that by the 60, you come out with 6.89 nautical miles. So for simplicity purpose, we'll use 6.9 as our distance. So now we have the two things that we can go ahead and use to find out our set and drift. So the next thing that we're going to start to chart and plot. So it says that our starting position is 41 degrees, 11.3 minutes north by 71 degrees, 48.6 minutes west. Okay, I've taken the liberty of already charting that. And if you look here, here would be our starting position. We chart it. We have our 11.3 nautical minutes, which I've marked A. I've marked our longitude of 7148.6. I've used our parallel rulers and I've walked over to 285 degrees. And I'll do that quick demonstration. But we lined up our ruler at 285, our parallel rulers, through the center, and then we walk it over. We would walk that over to our line, and then we would snap our line, or we would chart our line at 285 degrees. Next, we would take our compass, which I just lost. Okay, so now we have our compass, and we said it was 6.9 nautical miles. Okay, and so we can open up our compass to 6.9 nautical miles. Now you can use up here, but we all know that the latitude, each minute of latitude also equals 1 nautical mile. So we take our 6.9 and we chart it. Okay. And we mark our 6.9 and we use, this is our dead reckoning. And that is the symbol for dead reckoning. So this here is our dead reckoning. This is where we thought we would be. If we left and there was no effect of the current, no effect of the set and the drift, this is where we would wind up. But we didn't wind up there. We said 44 minutes later that we wound up at a latitude of 41 degrees, 14.0 minutes north, and 7158.1 minutes west. So let's chart that. I took the liberty for the test of this. This is our latitude, and here is our longitude that was just required of us, and we will do our charting. We take our parallel rulers. We make sure that we are directly on a parallel, and we walk it up very carefully. We walk it up to our point, and we chart with our first line. The second one that we do, now we have our latitude. We set up our lines again on our parallel ruler on a meridian. And again, we would walk that over, making sure that we are 100% on the mark. And we would draw our second point. This is point B. That is where we actually wound up. Okay? Now, we have all the information and we're ready to find our set and our drift. I said before that the set is the direction, the true direction of the water moving. And we said that the drift is the speed. So first we're going to find the set. All we need now to do is find the set is we go from our dead reckoning to our point B and we walk it back to a compass rose. Now normally I would walk to the closest compass rose, but this one is very busy. So I'm going to walk us over to this compass rose. So we very carefully set our lines up through the compass rose. Through the point B and through our, from our dead reckoning through our point B, and then we're gonna walk it over. Being very careful not to move the parallel things. And if you look here, you'll see that we are at 329 degrees. So our true is 329 degrees. So we can mark that down, 329 degrees. The last part of that question should be, what is the speed of the water? Now, since we're moving we've only gone for 44 minutes. So this distance that we have here, that we've traveled at, back on the chart, if we go back to our dead reckoning position, and we go back to our point B, and we're very careful, this will give us the distance that we've traveled in 44 minutes. We then will convert that through our D Street formula back to speed. So again, we can come over here, and we can use this to chart. And if we look here, we can see that we are at 9.9 of our nautical miles. So we say, okay, now we go back to our D Street formula. Now here, we're looking for speed. Okay, and we had distance. So it gave us distance, which was 0.9, okay, nautical miles in 44 minutes, because we're still looking at the 44 minutes that we started at. Okay, so now we just use the D Street formula, we plug it in, and we come up with our speed of our water, which is our drift. And if you take 0.9 times 60, okay, it's 54.9 times 60 equals 54 divided by the 44 minutes. You get 1.22, or we round it off to 1.2 knots. So the question asks us, what was our set and our drift? Our set was 329 degrees, and our drift was 1.2 knots. Thank you very much. Enjoy your day.